June 19, question number 27. Graph the following piecewise function on the set of axes below. I like to think of piecewise functions as functions in which we are reading from right to left in this direction. And these two set of inequalities are really just telling us what our function or how our function is acting at a certain place on our graph. Now, when I look at both of these inequalities, I notice that the smallest number is -5, and the largest number is 6. So I like to go to the side of my page and set a really long set of points. We have x, and in this case, we have f of x, or otherwise sometimes known as our y. So I'm going to make a real long set of values. And I'm going to include all of the numbers from -5 to 6. So I'm going to put a line for -5, -4, -3, -2, -1, 0, 1, 2. Now you might notice that the number 2 is in both the upper and the lower. So I'm going to put two different places for that on my set of tables. 2 again, and then 3, 4, 5, and 6. And I'm going to fill in all of those numbers right away, because that's really the entire extent of what we're going to be graphing. So x, -5, -4, -3, -2, -1, 0, 1, 2, twice, 3, 4, 5, 6. Now, another thing I'd like to do before I start even collecting the y or the f of x values, I like to kind of write onto my table what type of point I'm going to be using at that particular point. So I'm going to start with the -5. And I see that if I read this in this direction, always from the letter towards the number, it says x is greater than or equal to -5. That means that point is included in my graph. So the point I'm eventually going to write at -5 is going to be a solid point. I'm going to put that there so I remember that when I put that point there. Now I'm going to go to that first 2. And if I read this from the x towards the number, it says x is less than 2. That means that that 2 is not actually included in that upper part of this function. It means x is just less than 2. That means when I get to that first 2 down here, that point is going to be empty, meaning I'm going right up to it, but it's not included. All right, it's going to be an empty point. I'm going to put that there so I remember that when I put that point in. Now I'm going to go to the bottom. On the bottom, reading from, again, from the letter to the number, it says x is greater than and equal to 2 when I'm at that lower function. So that means when I get to my second 2, I'm going to fill it in. Now, it's true that sometimes these end up being the same point. And then it really doesn't matter that I had the empty one. But if they're different points, that's super, super important. And then finally, we go back to the x and it says x is less than or equal to 6. That means that last point in our function is also included. So I'm going to go down here and make sure remember that my point is solid. Okay. Well, the next part is, well, filling it in what the f of x is, what the y's are. So I'm going to go to my graphing calculator. And I know it says f of x is equal to, but on our calculator, that's the same thing as y is equal to. So I hit the y is equal to. And the first upper function up here says f of x is equal to the absolute value of x. The absolute value. Well, the easiest way to get to the absolute value is to hit the second button, the 0 button, which is our catalog. And the very first one, ABS, means absolute value. So I hit enter. And as you can see, that those 2 bars opened up, and I'm just going to put an X in there. And then I'm going to hit the right button to get out. So I just want to see what that looks like. So I'm going to go second graph. Actually, I might hit the graph first just to say, okay, oh yeah, that's one of those V's, V-type graphs, right? But I need to write in the values on my table, so I'm going to hit the second table, and I'm going to go hit my up button until I get to that -5. And now I'm going to fill in all of the values until we get to the first two, because that's what that means right over here on our graph, that the first graph exists from -5 to +2. So as I can see, it's pretty simple. They're really all just going down from 5, 4, 3, 2, 1. 5, 4, 3, 2, 1. Go back to my graph. 0, 0, 1, 1. And then there's one more. So if you really want to be extra careful, we're going to go put the 2 on the top now and see that it's 2, 2. Okay, there we have the first part of our graph. Now, if you like, we could graph those now. So I'm going to go to -5, 1, 2, 3, 4, 5, +5, 1, 2, 3, 4, 5. There's my first point. Remember, I'm filling it in, and I'm remembering that's a nice big solid point. Then -4, +4, -3, +3. Kind of can see the pattern there. -2, +2. -1, +1. 0, 0. 1, 1. And then this one, got to remember, this is going to be an empty. 2, 2. So I'm going to draw an empty point right there, right? Okay, so let's go back to our calculator. And I'm going to go back, and just so we're really clear, I'm going to clear that out so we don't get confused right now. And I'm going to enter the second function, which is -2x plus 10. And we should recognize that this is a linear function. I'm going to go to the second graph, and this one begins at 2, and we're going to do all the way to 6. So I can see 2, 6, 3, 4, 6, 4, 2, 0, 6, 4, 2, 0. And I bet that last one's going to be -2. It is. And now we can finish our graph. So I'm going to go to 2, 1, 2, 3, 4, 5, 6, and make sure that that's a solid line, solid point. And then 3, 1, 2, 3, 4, 4, 2, 5, 0. Remember that last point, 6, -2 is also a nice big solid line. Okay, so it looks like we're ready to connect. So we're going to put our straight edge down and go draw that straight line from there to there. And draw another straight line from there to there. Now remember, at +2, we have 2 points, one that's not included and one that is included, but we are not going to draw a vertical line. Remember, vertical lines are not a part of functions, but we're going to jump. This is this little jump up to our 2, 6, and then we're going to finish our line right there. And there we have it. This is our piecewise function. Now, the name of this function was f of x, so I might want to go here and maybe put a little f of x just to remember that that's what it was called. And there you have it. We just graphed a piecewise function. June 19, question number 34. Graph y equals f of x and y equals g of x on the set of axes below. Well, here we could see that the f of x is equal to 2x squared minus 8x plus 3, and that the g of x is equal to -2x plus 3. we might also recognize that the f of x is a quadratic function, which will graph into a parabola, and that the g of x is a linear function, which will graph into a line. Now, they haven't given us any domain here, so that we also have to remember that when we graph these to use arrows, that these technically will go on forever in both directions. Well, let's just get these into the calculator. So let's go back to our y equals, clear everything out, and let's put in the quadratic function first. So 2x squared minus 8x plus 3. You might want to hit graph just to get an idea of what it looks like. Now, I also like to do that because I also want to see more or less where my vertex is. You know, the vertex of my parabola. And then I kind of take that vertex and I kind of move up to see where my axis of symmetry more or less would be. And that helps me know which set of points I'm going to copy onto my paper. So it looks like it's more or less likely to be positive 2. So I'm going to go second graph. And I'm going to take that positive 2 in my x and put it in the middle of my screen. 7 points fit. And if you notice that you see this symmetry where 2 is -5, and then both above and below you see -3 and -3, and then 3 and 3 and 13. That's a really good bet that those are a good set of points to copy down onto your paper. Okay, so from -1 to 5. So over here on the side of my paper, I'm going to say x and f of x. I'm going to make enough room for 1, 2, 3, 4, 5, 6, 7 points. And again, we're going to go from -1 all the way to 5, -1, 0, 1, 2, 3, 4, 5. And then I'm going to get those points. So 13, 3, -3, 5. 13, 3, -3, -5. And then you can see they kind of repeat themselves. So I'm going to have a -3 here, +3 here, and 13 here. And there we have the points that will help us graph our quadratic function, which is the parabola. We might as well get that onto our graph. So -1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 0, 1, 2, 3. This is a nice long parabola. 1, -3, which is all the way down here. 2, -1, 2, 3, 4, 5. Over here, you can see they gave us just enough room to do this. And then we go back up 3, -3, 4, 3, and 5, 13. Now, when I'm graphing a parabola, you know, when you're really not connecting them with straight lines, we're trying to make it as round as possible. So I usually start at the bottom and try to make that kind of roundish, and with an arrow there. And I'm going to do the same, go in the other direction, try to make that round, try to go through those points, and arrow there. Yeah, that's not the best parabola I've ever made, but it is sufficient to what we're doing. I might want to, erase this part and make that a little bit better. There we go. Okay, and now let's go on to g of x, which is our linear function. Now, it's perfectly appropriate to also graph g of x, since it's a linear function, just by being able to take out our slope, which would be equal to -2, and our y-intercept, which is +3. If you're good at working with the m and b of a line, you could find the y-intercept, which is 1, 2, 3. And then do a slope of -2, which is down 2 across 1, down 2 across 1, down 2 across 1, down 2 across 1, or in the opposite direction, which is up 2 to the left 1, up 2 to the left 1. You really only need to draw the line as far as it goes through our parabola. So I'm going to connect those and draw an arrow and an arrow. And whenever you have more than one function on a graph, it's really good practice to label them. The parabola was our f of x function, and the line was our g of x function. But I also want to show that we could have graphed this equally with our calculator. I'm going to keep that other function, and underneath I'm going to put negative 2x plus 3 and go second graph. But just remember, when you put multiple functions in the graph, they're going to be sharing the x column, the domain, but then we have to look over at the y2 to see the points on the second function. Now, we could easily just extend our table here on the left side, right, and put our g of x here, and then just fill in the values: 5, 3, 1, negative 1, 5, 3, 1, negative 1, negative 3, negative 5, negative 7 is what I'm going to imagine them being. And we could graph that way. Okay, so we have both of our functions graphed. We finished the first part of this problem, but on the bottom we see there's another question, so we have to be very careful. So determine and state all values of x for which f of x is equal to g of x. Well, by saying when f of x is equal to g of x is the same as saying what are the values of x when these two functions are at the same place? Well, these two functions are only at the same place at their points of intersection. So if we were to answer this question graphically, we can just look for those 2 points of intersection and just ask ourselves, what are those values of x? Not y, but x. So I can see this first point over here, the value of x, that point is right on my y-axis, which means my value of x is 0. So right down here I'm going to write, well, when x is equal to 0 is one of the places. And there's another one over here. Well, there's another point of intersection, and the value of x for this point, this second one down here, is when x is equal to positive 1, 2, 3. So x is also equal to 3. Now that would be a solution by using our graph. Now if you come over and look at our table of values, we can also have answered that question over here. I'm looking at my g of x and my f of x, and I notice that both of them have the same value when the x is equal to 0. So that's how we can find one of them using our table of values. And then I notice that they also have the same value when the x is equal to positive 3. So we double checked our problem. And finally, I'm going to show you a triple check. And the triple check is something else that they're not asking for us to do right here, but we can always practice that. And that is the algebraic solution. And to find the values of x when f of x is equal to g of x, one thing that we can do is actually set them equal to each other. So I'm going to do a little bit extra work here, but it's important for us to practice. So we have our 2x squared minus 8x plus 3. When is this going to be equal to our g of x, which is negative 2x plus 3? Well, at this point, I notice we have something that is called a quadratic, because our highest degree exponent is 2x squared, 2x squared. That makes this a quadratic. And because we have an equal sign, it makes it an equation. So I know that one very nice way to solve quadratic equations is to first try to set the equation equal to 0, which means I'm going to bring that negative 2x and that positive 3 to the other side of the equation, put everything on the same side of the equation, and set it equal to 0. So I'm going to end up with a 2x squared My negative 8x is going to stay there. Now this positive 2x is going to go to the other side and change to a positive 2x. This positive 3 is going to stay there. But the other positive 3 is going to also go to the other side and become a negative 3. And now everything's on the same side of the equation, so it's equal to 0. Now I'm going to combine like terms, as I always do. And I'm going to have a negative 2x squared. There's no other x squared, so that stays the same. But I'm going to combine my positive 2x and my negative 8x and get negative 6x. And then over here, positive 3 minus 3 is equal to 0, so that disappears. And the other side is still equal to 0. Now, once everything's equal to 0, I'm going to begin factoring. And the first question I always ask is there a greatest common factor? And I notice between 2 and 6 that 2 is a common factor. And from x squared and x, it's x. There's a 2x greatest common factor. I'm going to open parentheses. And 2x squared divided by 2x is x. Double check that. 2x times x is 2x squared. That works out. Bring down the negative. And 6x divided by 2x is 3. Close my parentheses, is equal to 0. Now, as always, we learn to kind of tee off to separate our factors, set them both equal to 0. So 2x might be equal to 0, or x minus 3 might be equal to 0. And now solve each one. Well, divide by 2, divide by 2. Here we get x is equal to 0. Well, that was one of my answers. So far, I'm feeling good about this. Now I'm going to take that negative 3 and throw that to the other side, and it becomes a positive 3. And that was my other answer. Okay, same exam, right? We're doing all the graphing problems. June 19, question number 36. A system of inequalities is graphed on the set of axes below. And I believe they ask us 3 questions. State the system of inequalities represented by the graph. Then they ask us 2 other questions. Well, state what the region A represents and state what the entire gray region represents. Okay, so let's go back and do the first part first. Okay, first we need to remember that when we are graphing or talking about inequalities, there's really 4 different possibilities for the symbols that we're going to use here, right? We can use one of these. We're reading that from left to right is less than, is greater than, less than or equal to, greater than or equal to. And another thing that we should kind of remember is that when we're graphing, either of the top 2, where it's just greater than or equal or less than, right? When there's no equal to sign, this usually turns into a broken type line because the line itself is not included. And then we have the equal to as well. Those are going to be solid lines, right? Okay, so writing the equation. I like to take the approach to write the equation is that I want to try to find the m and the b, the slope and the y-intercept. If I can find those 2 things, it's really easy for me to substitute these into y. I'm going to leave the symbol out. M x plus b. So what's the m and what's the b? That's really my first goal. So let's talk about this broken line on the left side. I'm going to call this my y subscript 1. Okay, so over here on the side of the paper, I'm going to say, let's start off with y subscript 1. Now, one way to find the slope is to try to mark some of the points that existed on this, like I'm doing right here. Trying to find some points that I could use, because if I could find a bunch of points, it's really going to be a lot easier for me to find out what my slope is. So I could see, first of all, that dotted line going from left to right, in this direction, is going downward, which means that my m is going to be a negative. And the change of my y is going to be the number I put on top of my slope. So I could see that I'm going down 3 and across 1. Well, that would be negative 3 over 1, which is the same as a negative 3 slope. Great. Now, the only other thing I need to know is my b. Well, my b for that line is where it crosses over my y-axis, and I could see it crosses over right here at positive 3. So now I have my m and my b. So I'm going to leave the symbol blank for a second right here, and I'm going to fill in my mx plus b. Well, my m is negative 3, so I'm going to write negative 3x, and my b is 3. So my y1 is some symbol negative 3x plus 3. So let's try to figure out the symbol. Well, first of all, I notice that is a broken line. So I know it's going to be one of these top two over here. It's either going to be less than or greater than. So my trick is to go back to the y-intercept, we'll make it blue, of that, and ask myself, well, which way are we filling up? Which side of that fence, so to speak, is being filled up? And I can see it's kind of like the left side. But what I really want to do is kind of go up or down from that point and see if we are in or not in the solution. So if I go down from that, if I go in this direction, I notice that all of a sudden I'm stepping into the solution. Well, when you go down on the y-axis, that means you're going to a place where y is less than. So the less than symbol, going from reading it from left to right, is this one up here. So it's going to be y1 is less than negative 3x plus 3. So that's one of our inequalities. All right, let us go to the other one. We'll do that on the other side. We'll call this one our y2. Okay, well, I can already see that it's a solid line, so I know it's going to be one of the other two, but we'll get to that shortly. All right, now, I also noticed that reading this again from left to right, that line, the line itself is going up. So I know that I'm going to have a positive slope. So over here, my y2, remember it's going to be some symbol, mx plus b, and I'm going to try to figure out what my m and my b are. Well, I already know that my m is positive. Well, let's see if we can get some points on that one so we can do what we did with the other one, figure it out. Well, there's another point, there's a point, there's a point, there's a point. Now, I notice that from one point to the other, I'm going up 2, which is positive 2, and to the right 1. So that, I always put the up and down on the top and the left, right on the bottom. It's a positive 2 over 1, which is the same as 2, positive 2. So let's see if we can find our y-intercept. Well, our y-intercept is going to be right down there. Well, that line crosses our y-intercept at minus 2. So now I already have my slope and my y-intercept, so I can put the 2 in front of an x and minus 2. Now we just need to know what symbol to put inside, right? So what symbol? Now we already know that it's a solid line, which means it's going to be one of these two that have the equal sign below. Well, again, I'm going to go to my y-intercept. I'll make it green here so you can see what I'm doing here. And I'm going to see that, well, the side of this so-called fence that's filled is the kind of the right side, right? The gray region. So, but really, I don't want to think right, left. I want to think up, down. Well, if I go up, I'm not in it anymore. But if I go down, I am in that region. Well, down is less than. Well, that means that this y2 is going to be less than or equal to 2x minus 2. And now we have completed the second one. So let's write it down here where they're asking. It says, state the system of inequalities represented by the graph. Well, we have y1 is less than negative 3x plus 3. And y2 is less than or equal to 2x minus 2. And there's the first part. Now, as you could see, the next question is saying, well, state what region A represents. Well, if I were to highlight region A for us, we could see that all the different parts in region A have the lines that are drawn, which was a part of the solution of our y1. And it's also gray, which was a part of our solution for y2. Well, therefore, region A is the solution to the system where both inequalities were true. And the last question is to state what the entire gray region represents. Well, as we saw, the gray region was really just our y2 solution. So we can just write that down here. The gray, state what the entire gray region is only the solution to one of the inequalities, or what we said, we called it y2. And there you have it. Another good thing to practice, which is really not a part of this particular question, is finding a point that exists in the solution A. And one advice I want to give, and another question that might ask that, is to try not to pick a point which is near an intersection, or especially you don't want to pick a point on a dashed line because that is not in the solution. So if they would have asked to find any one of the many points that are in the solution, I like to find one that's really clearly in the middle of the solution somewhere, like say that point right there. And that point would be 1, negative 1, 2, 3, 4, right? 1, negative 4. But they didn't ask that here, but it's often asked in other questions.